All right, it looks like we're ready to go. Thanks everybody for joining us today. This is our PowerTips series number 5, talking about space optimization in restrictive environments. So we've got 3 of our experts here, I should say. We got Nick Vonyak. He's our application engineer for industrial, and also Midwest, right, Nick, for data center.
Yep, Central
We've
Region.
got Corey Leshin, who is our Corey Leshin, who's our application engineer for the eastern half of the country, and Chris Osian, who handles the western. My name is Doug Moore. I'm the industrial product manager here at Starline. So today they're going to talk about some of the, I guess, applications, issues, and challenges, and some ideas with regards to space utilization. So hopefully you find it useful. We really appreciate your time here today. It should take about 25 minutes or so. If you have any questions as we go, please just submit them through the chat box and go to webinar, and we'll answer them as much as we can as they come. And we'll leave some time at the end to answer some more questions. So I think that's it. I think we're ready to go. You guys ready?
Yep. Thanks, Doug.
Go for it.
I think so.
All right. So if you've attended any of the previous PowerTips, we like to keep this first slide here just as a reminder of the basics of Starline Track Busway. The power feed section would be where your field wiring comes in, whether that's from your transformer, UPS, maybe some higher amperage bus duct. That would connect directly into straight sections, T-sections, elbows. The shape of that layout is really dependent on what your application requires. We get everything from, I see a lot of straight lines, particularly in the data center world. AB runs over racks. I know Nick sees a lot more complicated configurations for manufacturing lines, facilities, things like that. Another note, these plug-in units can go in anywhere along that track. So it really does allow that flexibility to get the power that you need where you need it.
Thanks, Corey. And like Corey said too, these plug-in units right here on the right-hand side, this is what we mean by a plug-in unit. We're going to talk about those as we go through this presentation. If you guys haven't joined us before, keep that in mind. Just as a quick intro, this is what we're going to be as a plug-in unit. And this is just the basics here. So we'll move forward. What we really want to cover with you guys today is, like we said, optimizing your busway space in restrictive environments. Restrictive environments can be anything from a low ceiling data center. There's different areas where in industrial factories, you have heating and cooling units that are in the way. You might need to jump around them, maybe some columns or that you need to bounce around, and just different areas. Lots of things we run into with space-wise, but there are options out there for you. Okay, so this first one here, this is an example of 400 amp sizing. And Corey, you made a good point before too. Something to note, the T5 busway, this is a 400 amp T5 busway. The height of this doesn't change at 5.5 inches, right? So it's all roughly 5 inches across the board, whether you're looking at a 250 amp busway all the way up to a 1200 amp busway. It's all the same height. So we could associate the same type of thing here. So you have 3 ways to feed this. You have an end feed. Here's your dimensions shown on there. You have a terminal block unit, and you have an above feed. These 2 are applicable in anything 600 amp and below. Okay, but one thing we want to note is you wouldn't have all 3 of these on there. You're going to pick one of the 3 which works best in your area. Okay, so let's say, for instance, with this photo here, we say, hey, I don't have a lot of room between the top and the bottom of this, but my ceiling sits right above here. I want to get this busway all the way up to the ceiling as close as I can get to allow myself to have the right height of plugins and have a lot of room down below. In order to do that, we'll remove our feed, because that takes up a little bit of room in between here. You can see that takes up about 3.5 inches. That's an extra 3.5 inches we can gain going up to the ceiling. And then the above feed we're not going to use, and we're going to use a below feed. Okay, a terminal block unit, which hangs below the busway. And you can see we're only 13 inches from the top of the busway all the way down to the bottom of this terminal block. So we gained a lot doing that, right? So there's different units for different areas, right? Corey, do you see a lot of terminal block units being used in the data center? I see a lot of it in industrial, but mainly it's due to they want to cut voltage drop on a system that may be 500 feet long, where they'll say, hey, I want a terminal block almost use it as a center feed. Do you see the same type of thing where you're looking at space-wise in a data center for your terminal blocks?
The 2 places that I really see the terminal block being used in the data center world is similar to what you were mentioning with trying to split the center of a run. So if it's a customer that maybe has cable tray, has some lighting, has things above where the busway is. They'll run that terminal block right in the middle. The second would be these low ceiling height applications. Two specific areas I see a lot are outside Washington, D.C., with a lot of buildings that have a lot of history. The ceiling heights are really the ceiling heights. A lot of data centers going into the basements of those government buildings. And then, of course, New York City, where space is at a premium in every corner of that city. So I had an application in Washington where, it was the cooling vendors needed a bigger plenum than they expected. The ceiling height got dropped. We worked with a rep, worked with a customer. We ended up using a terminal block and an E90 plug for their installation. So between the height of the busway and the height of the plugs and the terminal blocks, they only needed 13 inches vertically the entire way down for their application. They do need that vertical clearance underneath the terminal block for service, but that was only at the end of the run away from the cabinets.
Cool. And I ran into the same type of application, come to think of it, Corey, you just reminded me. There was one that we did about a year ago for a grocery type store that was in the same situation. Their data center was like that, and they were saying, well, we have very little room. So we were looking at something that was the same type of deal. We had 13 to 15 inches to deal with, and it was what route do we head, right? And we ended up coming out with a product, or not a product, but we ended up coming up with an idea, and I think we did end up using the terminal block unit. And I know we definitely use an E90, and we kind of had to stretch these a little further than we typically would, but it still worked, right? We were able to get some, I think it was 460 or 560 receptacles on there, which are a pretty large receptacle, and we still made it work.
Absolutely. And even for really high density data centers, we call edge data centers, modular data centers, where you may be in a C container, might be very, very tight containment. The lower image we have here is actually two 225 amp busways stacked AB right on top of each other, similar to the image we showed last week. From the top of that plug-in unit to the bottom of the plug-in unit is only 9 inches total that you would need. So from a space containment point of view, that's 225 amps across two separate busways with 9 inches of vertical real estate. So we always say when you see these applications, people think overhead requires a lot more space in a data center than sometimes it really does. So working with the sales reps, working with us on the application engineering team, we may be able to reorient, use a different type of plug for your application where we can really shrink that space down.
Sure. And to put things in perspective, this right here is an E90. So this isn't a very large box. This is only 8 inches tall. To kind of give you an idea of what that actually looks like. It's not much. So you can fit a lot of power in such a small space. That's one of the big benefits of it, right?
Yeah, the plug that Nick has shown, the E90 and the T5 system, that's a 530 C6S. So that's a 30 amp 3-phase IEC receptacle that's very, very common in the data center industry for us. But we can fit pretty much any California style NEMA type receptacle on there as well, including metering as well as the breakers.
Yep. So that's going to bring us to this slide here, swing length. Okay, so this, we're looking at the front view. All right, the front of the busway with the channel facing down. This way, the channel's facing away from us, right? We're looking top down here. Swing length, what we mean by that is, okay, so take an E50 or E90, like I have here. You're going to put this up into the busway at 90 degrees, and then you're going to turn it, okay? That swing length right here, where that busway comes down and goes forward, is where you're looking at. So we've kind of showed you a little chart here to keep that in mind, okay? So these are listed in our O&M manuals, but I think the benefit to show you this is that in an application where we may be up against the wall, so say there's a wall right down here on this bottom side, we can't turn that busway in that bus plug in that way. So we need to sometimes know how much area we have out in front of the busway. For me on the industrial side, it doesn't really matter too much. I don't typically have things in my way. But in a data center, like Corey, you probably do see things like wire racks, right? I mean, there's usually a lot of clutter up there, right?
Absolutely. Space is a premium. And the other question we see a lot is customers that have A-B busways on the same elevation, where they think that they need a very discrete amount of space for each to be able to window and get in and out. One thing to remember with the T5 busway and our other busways is that those plug heads are what we call bidirectional. So you can rotate it in front of you from the front end or from the back in the same 90 degrees. So with an AB busway, you can butt those plugs up the entire way along the entire way and still be able to get them in and out without any restrictions. No, most customers always still want that window to be able to access and see the front of their circuit breakers. But with some of the longer plugs with multiple draw cords, multiple circuit breakers, you don't necessarily have to have a full window view of each, the front of each plug-in unit. We do have a solution also for some of those applications where you may not be able to rotate it, whether that's because of lighting, cable trays, any other type of solution that's in the way. We do have what we call our rotating paddle head. So with this plug-in unit, it's a special type of plug-in unit where the instead of rotating the entire plug, the paddle head rotates independently of the plug. So what you would do is install the plug with the paddle head running parallel to the busway, install, flip up both claws on each end, then either from the floor or from below, you would pull and rotate the lower lever at the bottom, and that would engage the contacts into the busway.
So what's actually rotating here, Corey, is this piece here, this bus plug. We don't have to worry about swing space with this bus plug anymore. It goes straight up into the busway, because if you look at this, see how our stabs face the front and back of the box? In this photo here, our stabs face the sides of the box. So this thing goes right up into the busway how you see it. You know, so if there is a lot in the way, say you got a wall behind you that's in the way, and let's say you have a rack in front of you that's in the way, you know, you don't have to worry about spinning this. You put that up in there, and like Corey mentioned, you turn that bottom piece on there, that bottom hook with a lever, and that locks this into place. And it's already locked up into place on the end, supported like mechanically wise, because your two claw designs on the sides.
Our standard plugs are still by far our highest runners, but this is just another tool in your tool belt for specifying engineers, for our sales reps, for our customers. Sometimes you may need just one of these per busway. We do have some customers that order only this type for their busways. So it's just another option that we have in our portfolio.
Sure. And then this one right here, I see a lot of this in industrial. Corey, I'm not sure if you see a lot of this in a data center, but what we're trying to show right here is this is just a rendering that one of our drafters have done for us here in the past, where we had a customer say, hey, I have a column. This is their column. They had to get around it with busway. How do they do it, right? So think about, they had an end feet down on this end, and this might have ran the 100 feet. They hit their first column, and they're saying, okay, what do we do? Is there a way to come back around? Do I have to pull more wire all the way back over to here and start again with a new feed? The answer is no. That's an option, but the answer is no. You don't have to do that, right? On anything 600 amp and below, busway amperage wise, you could use a terminal block like you see here. So all we're doing with this, we're turning a terminal block into here and here, and then we're just using a hard pipe conduit coming all the way across, okay, and bouncing back and forth. Do you see these in data centers, Corey? I see them a lot in industrial. You know, we do tend to have to come around air handling systems and columns more often.
The applications where I typically see this is where customers may have some data center rows that are staggered 90 degrees off, possibly for a feeder row that they want to connect from one of their other vertical rows. Or if there's additional risers based on how their building's set up, and a customer needs to have an elevation change in their busway. So that's another application for going from either terminal block to terminal block or another end feed to end feed, where that elevation change, you know, 45-degree runs of busway where we don't have necessarily a 45-degree elbow, any custom elevation change, angle change, especially in buildings where, you know, you have customers that are really trying to hug, you know, 1 foot, 2 foot off of the wall the entire way around. Like Nick has shown here with either columns, posts. I mean, Nick, we have in our facility back in Canonsburg, we have a very large HVAC unit in the newest edition we put on that those trunk busway that we run. If you're ever in the facility, you'll see we have some T3 busway that effectively the run stops right at the HVAC unit, conduit goes down above and below and connects right into busway on the other side. So avoiding obstacles, elevation changes, odd angle changes. These are just opportunities where, you know, you may not necessarily have to feed a another run of busway, a second or a third run of busway, where you can't connect and can't daisy chain off of that with the same protection.
That's a good point, Corey. I forgot about that air handler up there. I know exactly the same location you're talking about. So it acts a lot like truncating. So you could do the same type of thing doing it this way, right? We wanted to show you a couple pictures. This is one right here, which is obviously a restrictive area, right? This is an area where this was a washdown area, you know, in a lab, where the busway is actually above this ceiling, these ceiling panels up here. Okay, so it's above here. There are regulations and codes that you have to be careful with. Obviously, it cannot be in a plenum. This is not a plenum rated area, and this was allowed by code to be up in here. But you can see it's a tight area. We're not dealing with a whole lot of space here. You know, we're putting E90s in here, and then the busway is mounted right to here as well too. One of the things we did for this actual particular end user was, which we don't normally do, but we did the plug-in unit separate from the cords. All right, so we don't typically do the cord sets separately, but in this situation, the customer said, hey, if you guys wire these off and I buy these plug-in units the same way as they normally would, that means once they hit the site, I have to go through, open up your plug-in unit, unwire the load side of the breaker, remove this drop cord from there, slide it up through this grommet, and then try to reconnect back into it. And they're like, well, we don't necessarily want to do that. We said, okay, great. What we'll do is we'll do these whips separate. And then they purchased a seal-tight grommet up here that's watertight as well. Obviously, down below, we are using Meltrick connectors and then some Leviton watertight connectors as well too. Benefit of those is those can be washed down. Those are good in wash down areas. You know, it's not going to hurt anything. The busway is up and out of the way, out of any harm's way, right? So that's obviously a restrictive area where you want to look into. That's another way you could do it, right? And we come up with ideas like that. This situation, Corey probably runs into more of this. So I'll kind of let you talk about what happens here, Corey, right?
Sure. So it's we have customers, especially like I mentioned before, with very tight AB runs of busway that say, you know what, I have a 10-foot, 15-foot cable off of my PDUs already. I really don't want to have additional cord and have a connector laying on top of my racks. So we can, our standard mount is typically a front mounted receptacle, but either bottom mount receptacles as shown here, or even rear mount receptacles on some of our enclosures are possible for certain applications. So it's, in a lot of data centers, it actually gives a nice clean look. The strain relief is right in line with the box, so you don't have a cord hanging off towards the front, especially with a lot of hot aisle containment, cold aisle containment. Keeping everything vertically oriented versus sticking off out of the front sometimes really helps in some of those space constrictive environments.
Absolutely. Yeah, so guys, keep this in mind. You know, we can't do every receptacle on the bottom. Like obviously we have size restrictions. We can't put a 560 pin IEC connector on the bottom of there like a pin and sleeve. There are some units we can. It wouldn't be in an E50, but there may be some that some sheet metal enclosures that we can do that in. If it's an absolute requirement, let us know. You know, let your reps know, and we'll walk through it as well too with you guys and figure out what we can and can't do. But and like Corey said, in this situation, it's a nicer look, right? They're coming right out of their racks, straight up into there. They're not making this loop. They're not worried about wire bending space. They're going straight into there, locking it in place, and they're ready to go. So keep that in mind in those situations as well. And then we had Chris in the background here answering any questions. So that's about all we had for you today. That was our last and final power tip for you. And then we'll catch back up with you later. But Chris, was there any questions as we were going through this at all?
No, I think you guys did a great job presenting optimizing installation, especially in restrictive areas. There were no questions, so this is just a reminder to all on the call. If you do have a question, feel free to put it down in the chat, and we'll get to it either at the tail end of this meeting or we can follow up after this webinar as well. So with that, I'll pass it over to Doug.
Yeah, thanks, Chris, and thanks, guys, again for your time and all the input. So for everybody listening, hopefully you got something out of this today, learned something, maybe got some ideas, and I know they obviously answered all our questions, so that's great. But as you encounter different situations where you find yourself in a situation where you have space issues, definitely you know, contact your rep. Obviously, there's a lot of different options here, and you can contact us directly via online, email, phone. And if you don't know who your rep is in your area, you can either contact us or check out our link here below to find out who your local rep is. So This is our final webinar of the series, and we appreciate everybody who's joined either this one or any of the previous webinars. We will be considering some new topics in the future. So if you have ideas, we will be reaching out to everybody to maybe kind of get some feedback and possible ideas for future webinars. So with that, unless you guys have anything else to say, anything else you want to add, guys?
I think that's good, Doug. We do appreciate your time, Corey and I, and all of us as well. You know, like Doug said, if you guys have any suggestions with that you'd like to hear more about, reach out, let us know, and then we'd be more than happy to sit down and go over some things with you, either on an individual level or do another couple power tips like this in the future for you. You know, I hope you guys found it informative for you, and you've learned something out throughout the way here. We appreciate your time. All right.
Great. Thanks again, guys. Take care, everybody. Have a great night.
Thanks, everyone.
Take care.